Understanding Attention Mechanisms in AI. Hey everyone, and welcome to Code Grads. Ever wonder how AI can understand long sentences, translate languages accurately, or even summarize a giant news article? A big part of the magic is something called attention mechanisms. So, why all the buzz about attention? First, it tackles a huge challenge: long range dependency. Imagine reading a long paragraph and needing to remember the very first sentence to understand the last. Attention helps models do just that. To really appreciate attention, let's look at what came before. Standard sequence to sequence, or sake to sake, models had a limitation. The encoder part would read an entire input, say, a sentence to be translated, and compress its entire meaning into a single, fixed size vector. Think of it like trying to summarize a whole movie into one single word. You'd lose a lot, right? This squashing meant important details, especially from earlier parts of the input, could get lost. Attention mechanisms came to the rescue. Instead of that single, compressed vector, attention allows the decoder, the part generating the output, to selectively look back at all relevant parts of the entire encoded input at each step of its process. It's like giving the model a memory or a focus capability. It's not just about remembering, it's about knowing what to remember and when. Now, let's look at some types. First up, additive attention, often called Bahdanau Attention. Imagine a little helper neural network. For every word the model wants to generate, this helper looks at the current context from the decoder and each part of the input from the encoder. It then calculates an importance score by combining, often adding, hence additive, these pieces of information. This score tells the model how relevant each input part is right now. Next is multiplicative attention, also known as Luong Attention. This one is a bit more direct. Instead of a separate mini network for combining, it calculates relevant scores using direct multiplicative methods like a dot product between the current decoder state and all the encoder states. It's quite flexible and efficient, especially when the internal thinking dimensions of your encoder and decoder match up well. Now for a real game changer, self-attention or intra-attention. Here, the inputs essentially pay attention to themselves. The model looks at different words within the same sentence or sequence to understand context and relationships. For example, in "the cat chased the mouse because it was fast," self-attention helps determine if it refers to the cat or the mouse by weighing the importance of other words in that very sentence. Multi-head attention, which is foundational to the famous transformer architectures. Multi-head attention takes the power of self-attention or other attention types and amplifies it. It's like having multiple experts or heads looking at the input simultaneously, each from a slightly different perspective. Each head performs its own attention calculation in parallel, focusing on different patterns or relationships. Their findings are then combined, giving the model a much richer, more nuanced understanding of the input. Machine translation. This was the birthplace of attention, allowing models to align words accurately between languages. Text summarization. As we discussed, picking out the crucial sentences from long documents. Question answering. Finding the exact snippet of text in a large document that answers a user's question. So, let's boil it all down. What are the absolute key takeaways about attention mechanisms? First, they are the solution to major hurdles like long-range dependency, forgetting early information, and the information bottleneck, trying to squash too much info into one fixed summary. Attention gives models a better memory and focus. Second, the core idea is allowing models to dynamically weigh the importance of different input paths. It's not static. The focus shifts depending on what the model is trying to output right now. And third, we've seen the main types from the foundational additive and multiplicative attention to the revolutionary self-attention and its parallelized powerhouse version, multi-head attention, which are critical to models like transformers. Understanding attention is fundamental to understanding how many of today's most advanced AI systems work.